हेलो एवरीवन, वेलकम बैक टू द लर्निंग फील्ड। तो देखो, आज इस वीडियो में एक क्वेश्चन डिस्कस करेंगे। वो है CSIR नेट 2023 का एक रियल एनालिसिस का क्वेश्चन है, ठीक है। एंड द क्वेश्चन ID is 704064। सो दिस इज वेरी गुड क्वेश्चन फ्रॉम यूनिफॉर्म कंटिन्यूटी। ओके, so the question says that let a from 0 infinity to r be a periodic function of period 1 given that fx is equal to what? Fx equal to given fx equal to 1 minus mod of 2x minus 1. Okay, for x belongs to 0 1 and x belongs to 0 1, define g from open interval 0 infinity to r by gx is equal to f of x square. Then which of the following options are true? F is continuous and uniformly continuous, G is uniformly continuous and continuous. Okay, so देखो, this question we all know that the mod function is obviously continuous. There is no problem of continuity. So this is obviously continuous on interval r. Okay, and from x 0 to 1 continuous, and this is also 1 minus mod of 2x minus 1 is also continuous, and therefore f is continuous. Okay, f is continuous, this is almost sure, and it is given that f is a periodic function. That means f is also periodic. So that means continuity plus periodicity implies uniform continuity. You all know that if a functions f from r to r throughout r to r, if f from r to r is continuous and periodic function, then obviously it is uniformly or uniform continuous. Okay, so that means f is continuous as well as uniform continuous. There is no issue. Okay, so f is continuous and f is also uniformly continuous. Now the concept of g. So it is given that g of x is equal to f of x square. Okay, so that means f of x square means 1 minus mod of 2 of x square minus 1. Okay, fine. Also see, this function is again a continuous function, as we know that any mod function of mod x is continuous, no problem, and 1 minus 2x square minus 1 is also continuous. The problem comes in the mod function in differentiability. Okay, we all know that if a function mod of x minus a, then it is not differentiable at x equal to a, but it is obviously continuous throughout the real number. Okay, so not only the case of mod function is it is not differentiable at the point a here, if a mod of x minus a. Okay, so g is continuous, there is no problem. That means this option is also true. Now the fourth option comes, says that g is uniformly continuous or not. Now if we see that, we know, if we can apply a concept which is, see, if f of g or f of not g, phi of psi. Okay, if there are two functions or compositions of functions phi of psi, then this is says that this phi of psi is uniformly continuous if this psi function is uniformly continuous and this phi function is bounded. Okay, now here it is says that gx equal to f of x square. Okay, now this x square function, we all know that the interval is from 0 infinity to r. Okay, and this x square is not uniform continuous in this 0 infinity. We all know that if x square is uniformly continuous on only in the closed interval, suppose 0 1 or any closed subinterval of r, but it is not uniformly continuous in this interval or throughout r. Okay, it is not uniformly continuous. That means this type of function, if we say that g of x square, that is if we take phi is equal to g and psi is equal to this, then this phi function is not uniformly continuous over the interval 0 infinity to r. Okay, so therefore the function g is uniformly continuous. No, this option or this function g is not uniformly continuous. You can say like this. This is another an approach, and you can also say another approach that in the interval 0 infinity, since the quadratic function x square, and we all know that the quadratic function in the interval r or any interval, any infinite subinterval of r, in this quadratic function is not uniformly continuous. Only the linear functions is uniformly continuous throughout r and any subinterval of r, but the quadratic function is not uniformly continuous on R or any infinite subinterval of R. The quadratic term is uniform continuous only in the finite or closed subinterval of R. Okay, so or bounded subinterval of R, you can say also that. So this is the concept behind this questions, and you also remind this thing that whenever you have to find the uniform quantity of these types of comparison of two functions, then always remind that the function, suppose f of g, then this function g must be uniformly continuous and f must be bounded. Then the composition of these two functions is uniformly continuous. Okay, so here option 1, 2 and 3 are 3. So hope all you would like this problem, and I think you all are understand this solution of this problem. If you understand, then obviously give a like to this video. If you can say anything in the comment section below, you can say also. Okay, thank you. Bye. Milta agla video.